Hello students, today we are going to discuss about the non-deterministic push down automata, that is also called as NPDA. So before going to this NPDA, we will discuss what is this NPDA. Okay. So in PDA we have two types: deterministic PDA, which we call it as DPDA, and non-deterministic PDA, which we call as NPDA. Now what is the difference between these two is, in till now whatever problems we have done, that is designing of languages like 0 power n, 1 power n, or WC, W power R, okay, and 0 power n, 1 power 2 n, whatever problems we have seen, in all this we were doing only one operation at a time, that is for each symbol 0 we were pushing, and for each symbol 1 we were popping. Similarly WC, WR, all W's we were pushing and all WR we were popping. That means at a time we are doing only one operation. Okay. In case if you are doing two operations, that is you are pushing W here, when WR is starting, if you are showing both push and pop operations for the same symbol from WR, it means you are giving two different transition paths. As we have seen in finite automata, if there is multiple paths, we say it is non-deterministic finite automata. Similarly, if you are showing two different operations for the same symbol, like you have ABB, W, C, and then for WR we have BBA. So here what we do is, on top of Z0 we push A, B and B. So after C, at point of C we are just reading, and when B starts at WR we were just popping this B and this B. But here instead of this, if I am showing two operations, like one is pop this B and this B, and another operation is I can push WR also on this, then it becomes non-deterministic push down automata. Okay. So till now whatever problems we have done, all are deterministic push down automata problems only. And in the question, if it is asked to design a PDA, it means deterministic PDA only. Okay. So if it is a non-deterministic PDA, they will definitely mention in the question like design NPDA. Otherwise, if it is not mentioned, by default we have to design deterministic PDA. Okay. So coming to this problem, now here we have design NPDA for following language. Okay. So W and W power R is given. This is similar to W, C, W power R problem, which we have designed for DPDA problem. Okay. So here C is not there. So what we do is, the procedure is similar one. W and W power R is there. We will push all W into the stack, and when W power R starts, we have to pop. That is for when we solve deterministic PDA problems. Okay. Now it is asked to do NPDA. So in NPDA, when WR comes, we do both operations. First we will pop the first symbol of WR with the last symbol of this, as well as we will also show what happens if we push the first symbol of WR over the last symbol of W. We will show these two transitions. Okay. Then if that means we are showing more than one transition, then it becomes non-deterministic PDA. That means we cannot say exactly which transition path will be chosen from that particular designed PDA. Okay, we cannot determine. So that's why it is called as non-deterministic. Okay, so here we will take some states. We require some states for solving this problem. So let us take Q0, Q1. This we are assuming. Okay, since it is given 0 or 1, we are taking input symbol 0 or 1. Okay. So now what we are doing is, we are using replacement operations. So whenever we push 0 onto the stack, we will push it as symbol B, that is B for blue. Okay. So this type of replacement operation we are going to use only for NPDA. No need to use this replacement operation in normal DPDA problems. Okay. And whenever we are pushing 1 onto the stack, or whenever we are popping 1 with respect to 0, okay, we will use the symbol G, which stands for green. Okay. And the default symbol on the stack is Z0. So these are the symbols which we use on the stack. If we use 0 or 1 on the stack, then no need to show G and B, simply we will take Z0 as a symbol. But since we are using these two symbols which will be pushed onto the stack, we have to compulsory mention here, because these are two new symbols which are not given in the question. Okay. So for design of NPDA or DPDA, we need all these things: states, inputs, stack symbols, transition, initial state Q naught. Then this is a default symbol Z naught, which should be present by default, and this is the final state. Final state here is null. Okay. Now Q is equal to the states Q0, Q1, and sigma is equal to 0, 1. Tau symbols, that is the symbols in addition to Z naught, what are the other symbols we are taking onto the stack are B, Z, okay, along with Z naught. Q0 is initial state, F is equal to final state, that is null. Okay. So for evaluating WWR, we need to take some example strings which are a combination of 0, 1. So 0 plus 1 indicates you can take zeros and ones in any fashion or in any order, and star implies that minimum string is epsilon, 0 and 1. Here 0 and 1, when both are epsilon, you get minimum string as epsilon, that is you have a direct transition from initial state to final state. Okay. So let Z naught be the top of the stack symbol. Whenever we are inserting 0 onto the stack, we will insert as B. Okay, instead of showing it as 0, we will show in the stack as B. And whenever we are pushing 1 onto the stack or popping 1, we will show its status as G on the stack. Okay. So B and G will be shown onto the stack whenever we are doing push operation. Okay. And when we are popping 1, then G is not shown onto the stack, because you are not keeping 1 onto the stack. Okay. It is popped from the input type itself, then no need to use G. Okay. So let us take some example strings, because 0 and 1 is there, we will take some strings. Let us take minimum string of length 2, that means this 0 is W and this 0 is WR. Okay. So first this is similar to WC WR problem. First we will try to push the strings which are present in W, then we will add 2 or more transitions, that is push, pop, different operations we will add for WR. Okay. So first when you insert 0 onto the stack, 0 is comes over the Z naught. Okay. So it will be 0 Z naught. So instead of pushing 0 as it is, we will push 0 as B instead of 0. Okay. Then when second 0 occurs, it means it is a WR. Okay. So when WR is there, you can either pop this with this 0. So WR starts, this 0 and this B can be popped. So this cell will be empty, then this is a pop operation. You can also push 0 onto this and it will become BB Z naught. So it will become Q0 BB, because initial B is push operation W and second 0 is also push operation. So no need to change the state, we will simply write it as Q0 BB. Okay. So here we are showing two transitions for a machine. So that means from Q0 you are showing two operations, that is push operation as well as you are showing a pop operation. Okay, for this. Okay. Okay. So that's why when two different transitions are there for the same push operation, this is called as NPDA, non-deterministic transition. That means we cannot say that for a given input, for this second 0, we cannot say whether the transition, the operation which this machine will take, whether it will take push or pop. Okay, since we cannot determine, this is NPDA. Okay. So when this total stack is empty, when you do pop operation, this stack will become empty, or when you do push operation also, you are pushing this B onto this, so this stack, this input tape will become empty. So then this will be epsilon, and this third transition, it indicates only pop operation. When you remove 0 and this B, that is this 0 from input tape and this 0 from stack, this total input tape will be empty. When you remove this, only Z naught will be there, and this Z naught will be passed to the final state. Okay. So this you can take it as QF. Okay. So these are the states. Okay. Similarly, you can also check this same transition with one string. One more string we are taking as example. One is pushed onto the stack, it becomes G Z naught. Then again one is pushed onto the WR, this becomes a WR and this is W. So when WR comes, you can do either push or pop operation. So two different transitions you are showing, this becomes NPDA. If you show either this one or this one, it becomes deterministic PDA. Okay. So after pop operation, you can extend the transition with this. After push operation, input tape is empty, there is no other extension for this operation. So your state will stop here, okay, and it will become the dead state. From after this operation, you cannot do any other thing, you cannot go to the final state.